And good afternoon. Welcome back to our online class. And today we are going to discussing about the mineralogy. In the last class, we last 3 or 4 classes we discussed the crystals and how they were formed. Crystals.
Good afternoon, sir.
Different types of crystals are there, or the classification of crystals also have seen. And the crystal classification and the formation of a crystals, and which are useful for again to study of minerals and the identification of different minerals in different rock compositions. So, yeah, yes. Wait, please. Yeah, yeah, yeah. What is mineralogy first? We know that in a first semester, I hope we have studied about a different formation of a rocks. So here, the rock it is aggregation of different minerals. So these minerals were the mineral word where we have a listen the hard in first semester in general, the formation of a rocks in like example for igneous rocks, sedimentary and metamorphic rocks. These different types of rocks were formed based on the or aggregation of different minerals. I mean, a group of minerals or various type of minerals which are leads to formation of rocks. So now, what is a mineral? The study of a mineral it is known as a or the study of a minerals known as a mineralogy. Mineralogy. Yeah, how the minerals were formed. Yeah, actually the mineral in crystal also what we have seen in a crystal it has a inorganic substance and it has a definitely crystal structure there and it is a formation of a definitely chemical composition. Every crystal whatever it is that. Here also same similar to that. A mineral naturally which is occurring homogeneous and inorganic substances and having a distinct physical properties and definitely it has a chemical composition that is known as a mineral. So minerals sometimes we see it is in a group of a minerals. These different formation of a minerals or a group of a minerals which are leads to formation of a rock. So that so that here the mineralogical compositions we need to get. Okay, mode of formation of minerals. If you see in our textbook, it is mentioned the mode of formation of minerals are different. Based on it is classified based on yeah, it is classified based on the formation of minerals and availability of silicates in a minerals. So here rock formed minerals are there and rock forming minerals that is known as a rock forming minerals and second one it is ore forming minerals. So here whatever maybe it is that these are having the different elements and these elements are leads to formation of different minerals. So here uh, various types of minerals. Example for suppose if we can see that silica, oxygen, aluminum. These are three major components on the Earth. Silica and oxide. Every rock you can check it. Every rock it has a silica and association of oxygen. Excess few minerals like salt mineral you see that is NaCl. The composition it has NaCl or a fluorite NaF like that. Some of the minerals we are unable to find out the silica associated or silica oxide associated minerals we are unable to find out. So here directly some of the minerals which are formed from the um, magma. Those are best example for that quartz, feldspar, pyrox, and amphiboles, micas, and alumina minerals like that. And these rocks are getting the weathering and weathering, precipitation, and after that deposition. This process it is known as a secondary process. Here we are unable to find out the silica. It's very less composition of silica will be there, or sometimes maybe it is a lack of silica. So silica it is not presented here. So the best example for this one calcite, CaCO3 composition, dolomite, bauxite, Al2O3 days, coal, and petroleum. These are all will be formed in a secondary process. And third category, it is in the presence of a high temperature and a pressure without any involvement of uh, active chemical active solutions will be there something. And uh, the chemical composition may be changed so that here the original formation will be changes. Such type of formation it is known as a metamorphism. And these are metamorphic rocks example for we see the garnets, chlorite, and graphite. Here, there are some words are there for to know about minerals. In a particular minerals, if you see here, these words we will call that is known as a isomorphism and pseudomorphism. So these words we can listen. Uh, yeah, these words we can listen. Isomorphism, see, it has a peculiar and a natural phenomenon. We see minerals which are appear to be in different pictures and different mineral and different minerals will be there, and the chemical composition also we can see here. And this type of a called as isomorphism. It is which is saying there's an example for this one: feldspars, pyroxenes, amphiboles, and uh, garnets. Here, the first one it is the rock forming minerals based on the silicate and silicate associate or silica availability of a silica formation, availability of a silica formation in a different rock. The silicate formation or a silica rocks are occupying the first place in a rock forming minerals on the earth's crust. So here we see this is the silica structure or silicate structure. It is known as SiO4. SiO4 tetrahedron links will be there, and fundamental unit of a silicate mineral it is SiO4. The structure of silicates you see one it is a neso structure, second one it is the soro structure, soro silicate structures, third one it is inosilicates, fourth one is cyclosilicates, fifth one is phyllosilicates, sixth one is the tectosilicates. See here, uh, these silicates availability and formation of a silica with oxygens with oxygens. In a nesosilicates, we see here the silicate structure in a nesosilicate, the composition almost it has 95 percentage of the silicate minerals, which are having the 60 percentage is a feldspar and the 12 percentage of quartz. In a quartz group, you see here the SiO4. You see here the SiO4 occurs. It is an independent unit Anywhere you can see it is a quartz, quartz, SiO2 and SiO4. There is a differentiation. It is there. I'll explain that also. Silicon and oxygen relationship, it has a tetrahedra. Tetrahedra link will be there between these two. Independent tetrahedral groups and double tetra structures. Double tetra structures also there, and ring structures. Ring structures are known as the cyclostructures. I'll tell you that. Independent tetrahedral group, it is known as Si, yeah, SiO4. SiO4, and along with that another chemical component, or another chemical element will be there. Example for, if you see the forestite. Forestite, it is alvin group of a mineral. It is alvin group of a mineral forestite. Mg2SiO4. Mg2SiO4. So here, here it is one one element that is known as a magnesium, and silica will be there, and O4. SiO4, it is associating with a linkage with a bond of this one Mg, and which is forms to uh, forestite. It is formed to forestite, and it is called as a uh, nesosilicate. Neso means here island. Neso meaning it is known as a island, means single silicate structure. It is single silicate structure. It is known as a nesosilicate. And garnet is also best example for this one. Garnets and forestite, like Alvin group of minerals. The second one, it is double tetra structures. Here we see the same, the composition, it is a double tetra silicate. Yeah, no oxygens. Maybe here oxygens. Sometimes maybe oxygens here doubled, so that the oxygens, whenever the oxygens will be doubled. Example for SiO8, maybe Si2O8, Si2 ions of silica, and 8, almost 7 to 8 ions of oxygens will be uh, bonding with mineral, with other composition of elements. So here it is known as the sorosilicate. The SiO2 occurs in the pairs of a unit, and here also some amount of garnets, some minerals of garnets are the example for this one. And for this example, hemimorphite, Zn 4Si2O7, OH2 and H2O. The group will be formed here. The silky structure will be forming. So next one is inosilicate. Here the inosilicate. Here the inosilicate SiO2 occurs chains, like it is as a chain structure. It has a, say, a chain structure. So these are strain structure. Maybe it is a continuous formation, one to one silica to the another, and one oxygen to the another oxygen. So here another silica. The ratio between here silica and oxygen, it is 1:3 in chain formation. If it is a single chain, Si is to O, or it is one silica, it is uh, relation of a bond with three oxygens. And double chains, we see, suppose if it is a double chain, four silica atoms are there, and these four silica atoms in the relation of a 11 oxygens. It is relating with the 11 oxygens. So according to that, the chain silicates will be forming, or the chain silicates are known as a inosilicates also. And cyclosilicates. The cyclosilicates are known as a ring structure, which are having the ring structure. And here also we see the same, the uh, resulting almost it is 1 is to 3 here also. One silica, maybe if it is one silica, it is there, and the three ions of oxygens will be seen. So here Si3O9, the composition will be there. Here the best example for this one, yeah, this one bentonite. The bentonite, yeah, bentonite. It has a bentonite. We see here the composition BATISI3O8. That is one composition, and it has a tetrahedra and tetrahedra structure. The beryl also best example for this one. It has a six tetrahedras. So that here the we say the beryl composition Be3Al2Si6O18. Be3Al2Si6O18 with six tetrahedras are there. Almost it is a ring structure. The like a structure it has. So we will call the cyclosilic. So means is a ring. So means it's a ring. So, so here the uh, the pillow structure it is. The pillow structure it is known as we will call that is known as a sheet structure. Here the ratio of silicon oxygen is 2.2 is to 5. Sorry, 2.2 is to 5. Yeah, for this the best example for this one micas. Whatever mica you see, whether it is biotite mica or maybe you can see it is in muscovite mica. Whatever it is that here the mica group of minerals are the best example for this one. The ratio for these two, the ratio for these two elements, 2 is to 5, 2 is to 5, and the last one it is a tectosilicates. The tectosilicates, it is these tectosilicates are known as a framework structures, which are having the framework structure, and three. It's also we can see in a three-dimensional network system. Network system here, the silicon and oxygen ratio it is only 1:2 here. 1:2. These tectosilicates are known as the framework silicate. Framework continuously which are participating in a framework. Mm, For example, for this one, feldspars and the quartz are the best example for this for this structure. So there are some physical properties also it is required to study of a minerals. What are those physical properties we see? Wait. Yeah, this is outline of a mineral actually. Some of the characteristics and these characters are required for this one. What are those characteristics? It is formed naturally. It should be in a solid formation, and which is formed by the inorganic process. It has a crystalline substances and definitely chemical composition. It is required definitely chemical composition. So you see here physical properties of minerals now we are going to see. You see here different types of colors we see. It is a granite of a rock. This is a granitic terrain of a rock. It is, and second one is pink granite. After cutting off that one, this is the sample. After cutting that, you see in laboratory also. If you can next in your next practical classes, yes, you see uh, these type of rocks we are able to see there in a laboratory lab. It is a pink granite rock because of the pinkish dominating here. It is the surface you see here. The surface it is a polished. After cutting, we will get the polished, and it is a quartz formation. Quartz rock. This is you see here color. The first thing it is a color. How the minerals are seen in a different colors, appearing in a different colors. The colors you should identify. So you see here it is granite. Normal granite also you see it outside, and it is a pink granite.
That
Most
pink color
the rock
mineral,
we can see it is pink and quartz. This is the quartz and hornblende, amphibole group of hornblende. You see, it's orthoclase. Orthoclase means here white feldspars and orthoclase pink feldspars here. Okay, these are only just for your knowledge purpose. I am showing you here. These are exhibiting the different colors here. First, you see the color. So just keep in your mind these colors or these outline. Just you what you have seen. Keep in your mind. Yeah, there are different physical properties are there. While we are observing the minerals. So depend on your light. So here the minerals are having the different types of colors. So what we have seen here, you see different colors are there. They are exhibiting the different colors. So these colors we need to identify on every mineral at outside. Now you can apply that color. What are the colors you have identified? What is the use of that color? Suppose example for you can see carbon. Carbon means a coal. Coal we can see it is in a black color. Coal we can see it is in black color. Why? Because of that the nature. The nature. The carbon it is a formed. The carbon it is a having the black color there. So that it is exhibiting that. The same property, the same you can see diamond. The diamond it is also the composition. It's also having the carbon but it has a different it is exhibiting the different colors because of the formation it is a different here the carbon in a coal we will call it is a sedimentary formation but whereas the diamond it is a igneous formation so the formation mode of a formation it is a different there the origin of a formation it is a different there in both of the rocks so that is the reason the formation and arrangement of arrangement of atoms like a carbon or alumina or oxygen in different minerals are forming in different conditions so that is the reason different minerals are having a different colors different colors so that yeah you see some of the minerals what we have seen like a quartz what we have seen it is a colorless such calcite or the barite or aragonite is also same colorless light color the fluorite or orthoclase and orthoclase where we have seen jasper malachite and in for future definitely you'll get a knowledge about this that means that every mineral it has a own color maybe it is color or black color or red color or light colors which is exhibiting the different color this is one of the physical property so in examination point of view they'll ask a question they'll ask a question right about the physical properties of a minerals so that now you can start that physical properties of those colors you see here these different types of colors are there for different minerals. It is a transparent quartz and this is a translucent quartz and it is a transparent crystalline quartz and milky quartz, and it is amethyst. It is a smoky quartz. These are all the quartz only. Almost we'll get 6 to 12 types of a quartz we have. But quartz chemical composition is the same, but the color it is a different here. The color it is a different. So the quartz it is exhibiting the different colors in the formation of and availability of a, at the time availability of at the time of a formation. So that we see that is in different colors of a quartz we can see. Yeah, the second property it is we see the second property is a streak. The first one it is a color and second one it is the streak. So what is the streak here? The streak it is giving the color of a mineral in a fine powder. In a fine powder, it is known as a, yes, the property it is known as a streak. It has a streak plate. In a laboratory, you will get a one white streak plate, and if you can rub or scratch on a mineral, you will get powder. The powder, different mineral which is producing, it is giving the different color. So now you can identify that color. So here, indirectly, it is giving the mineral color. Once if you scratch or streak on a streak plate, this you see here, this is a streak plate. It is a streak plate, and it is a calcite mineral. Now, hold in your calcite mineral. Now you can rub on this one, just scratch on this one, on the screen and the streak plate. You will get the color. White it is in a color. White it is in a color. So here, it is a non-metallic. It is a non-metallic, so that is we can see it is in a white color. Or sometimes maybe you see here it is a red, cherry red streak, the iron ore. Okay. So here the cherry red streak, you see, cherry red streak we will get. This is from a hematite. 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 It is give. Hematite is a iron ore mineral. You hold in your hand iron ore mineral of a hematite. Now you can scratch on this streak plate. This is a streak plate of white. So it is giving the cherry red color, cherry red streak of color. So metallic minerals, the minerals are again metallic mineral and non-metallic mineral. These two types of minerals are there. So metallic minerals will give color. Will give color. Non-metallic minerals we can see the powder. We can see it is in a white color. So this is the property of a streak. And the third one, it is a luster. The luster, it is speaking about appearance, appearance of a mineral surface. And suppose once if it is the light, maybe if it is a fall on mineral, on a mineral. So it is sometimes maybe it is reflecting, shining also we can see. Sometimes we are unable to see the shining. So here, according to that properties, always we will see here two types of a luster. One, it is a metallic luster, and second one, it is a non-metallic luster. Sometimes we will call them sub-vitreous luster and sub-vitreous luster also. Vitreous and sub-vitreous luster also. The minerals reflecting light and looking shiny. It's metal object. So those properties are known as a metallic luster. So sometimes we see if it is in a steel, gold, silver, or copper minerals. Those are having these the reflecting sense. The surfaces are having a reflective. So the property sometimes maybe we are unable to see. So these minerals, we can see it is in a black or very dark color streak, dark or black color streak. So these are the things under the light we will identify. Okay, some of the minerals are here mentioned. The metallic structures, like metallic structures, we see almost all the metals which are showing the metallic color or a metallic luster. The best example for this one, galena pyrite and chalcopyrite, those. And non-metallic clusters. Here, the non-metallic cluster, it is uh, you see the surface or mineral, it is not shining. It is not looking into the shining because of it's not having a metallic property. So it is known as a colorless or a very light color or streak will be appearing. So then we will call it is a non-metallic cluster. And here you see here A, B, A, B, blocker, and C, D, E, the C. Just keep in your mind. A it is almost we see it is in gold color. That is a pyrite actually. Actually, it is a pyrite. Second one, it is a adamantine luster. Third one, you see here the quartz. It is a vitreous luster. Um, D, it is a biotite mica. Biotite mica, we see that is a pearly luster. Pearly luster in biotite. And E, at the luster of a bauxite, it is a bauxite. It is a earthy luster. Different kinds of non-metallic lusters and their examples here explained. Adamantine, it is a luster display minerals such as diamond and garnet. Usually, it is due to minerals high reflectance index, which are having the high reflectance index. The best example for this one, diamond, zircon, garnet, etc. and etc. And vitreous, it is we can see it is very common in a polished glass sections. The best example for this one, quartz and feldspars. Sometimes we see it is in a tourmaline in vitreous luster. In quartz also we see it vitreous luster. Uh, and resonance. Here resonance silk means the dull are mentioned. And I'll share you. We have no time, so that's I'm going too fast, moving very fast. So some of the here it is mentioned. Yeah, transparent and translucent. This property also we can see, and some of the fluorescent minerals and the phosphorus minerals also we see, but no need to that. Here again, the next property it is a form. Crystal forms. Here different types of crystal forms are there. Uh, Crystal forms, crystalline structure of a form, and crystallized form, cryptocrystalline forms, and amorphous forms. These are the forms we see in different minerals. And arrangement of crystals here, where the arrangement of a crystals is, depend on their shape. The crystals will be formed or developed based on the crystal phases in a particular mineral. So the shape, according to shape and arrangement of a crystals in a mineral. that is known as a euhydral formation or subhedral formation or anhydral formation. The crystals will be developed very clearly and formed very neatly and systematically. It is known as a euhydral crystal formation. Second one, it is which are not formed clear and they're not even though they will arrange in a perfect manner, but not in a perfect. It is imperfect, and but the crystal sizes and the crystals will be recognized here. The formation it is known as subhedral. In a anhedral formation, the minerals which have no crystal base is developed. They are called anhedral crystal. Uh, yeah. And isometric forms and non-isometric forms. Here, when isometric forms, they'll arrange very systematically and continuously. And non-isometric forms, when the crystals are having the non-matching phases. So that is one reason. And mineral habits also here. Mineral habit means here the mineral shape, how they are formed, and the pattern it is also we will calculate, and the individual crystal and aggregate tends to form under the given set of environmental conditions there. See here, crystal habitacular bladed structure or fibrous structure or foliated and foliaceous structure, lamellar structure, prismatic habitative, tabular formation, these, and amygdaloid formation and Bertodile formation, columnar formation, stalactitic or stalagmitic, maybe it is concretionary and dendritic, granular, different piezolitic reniform formation. These are all will be there in a form. And after that, the form, the next property, it is a cleavage. Cleavage, the property, it is known as a break or a weak positions or a small lines will be identified on a surface. The scratches, small scratches or small lines or a small fractures will be identified on a surface. The property it is known as a cleavage. So here the cleavage it is also perfect and imperfect. These two. The cleavage planes, but cleavage planes we can identify them. Some difficulty it is known as a good cleavage. Or sometimes maybe we are unable to find. We are unable to find. So those are all very difficulty, and those are distinguished or different from a previous one. So those cleavages are known as imperfect. It is known the directions, different directions which are formed. The direction it is known as a cleavage direction. You see here, the basal type of direction, only one direction it has on the top, and the prisma direction it has two directions. The sides also we will consider, and you see here, and cubic means three dimension, rhombohedral, octahedral, four sets of directions we see. Yeah, cleavage directions, how we will measure the cleavage direction. You see the first one, it is, we can see that is a calcite in a, yeah, the first one, it is muscovite here. The muscovite mica, it is a muscovite mica, we can see it is only one direction it has parallel to the surface. And here in a calcite, we are on the surface, we see the one, two, three types of fractures, small cleavages we can see. This is orthoclase. Third one, it is orthoclase. Here in this case, two sets of two directions we see in a. This is question. It is a question in important. Uh, Write about the types of cleavages with examples. In examinations, they will ask questions like this: what is cleavage? Explain with examples and types of cleavages. Two set of cleavages, three set of cleavages, two set of cleavages for the example for orthoclase, and three sets of cleavages are best example for calcite, and one set of cleavages we can see it is in a mica. So here the cleavage directions, the fractures, small fractures are plotting very poor cleavage. Also we can see that is known as a parting. So that is the one physical property. Yeah, and one more, it is a fracture. The fracture cleavage is a plane of a weakness along with the mineral break. The broken surface may be smooth and flat or uneven. When you break a mineral in a random directions, the cleavage planes or the broken surface would have two typical characteristic feature, which is known as the fracture. The fractures, again, the fractures you see here, sometimes maybe it is a even or uneven or a subeven. Based on that, the fracture will be defined, and the fractures surface, if it is a flattened or not cleavage, it doesn't have any cleavage. The best example for this one, chest and magnesite. Uh, Uneven or irregular fractures also we can see sometimes. If you can break in that one, it will be broken into the different parts or different angles will find out. So it is known as uneven. And conchoidal means the parting, it is very poor here, very poor. Yeah, these are the pictures you can see here. The first one, it is a conchoidal fracture. We see it is in a quartz. Second one, it is a splintery fracture in a kyanite. Yeah, one more property, it is a hardness. The hardness, it is one of the most important diagnostic property of a mineral. Yeah, it is the resistance offered by the smooth surface or mineral against to the scratching. So it is a might also set to the scratchability. Hardness of a minerals depends upon the arrangement of atoms, different atoms, how they were arranged, and it's giving the strength, the atoms which are giving the strength, where maybe it is associating very closely or sometimes maybe which are not associating very close. So automatically the hardness will be depend. It was the familiar German mineralogist Friedrich Mohs. He was classified in 1812 the minerals which are classified into the 10 categories according to their hardness. There are 10 minerals are classified into that category. The You see here the
Excuse
first
me,
one,
sir.
it is this column, you check it here. This
Sir,
column, the first one, it is hardness of a number, and second one, it is a mineral hardness of a mineral. Third one, it is a mineral with the similar properties of a similar category.
sir, there is a doubt.
Yeah, the hardness, mole hardness scale, we will call this is known as a mole hardness scale. It's giving the continuously with the respective of uh, mineral. Hardness mole hardness one, it is mole scale, mole hardness one. It is started from 1 to 10. 1, it is reference for talc. Based on the talc, if you can scratch, we will get a very fine powder from this talc, like a talcum powder. Yeah, second one, it is a hardness of gypsum. Third one is a calcite. Fourth one, fluorite. Fifth one, apatite. Sixth one, orthoclase. Seventh one is a quartz. Eighth one is a topaz. Ninth one is a corundum. 10th one is a diamond. You see here, based on the mineral category, minerals. You see, these are all the minerals only. The minerals are having the different hardness properties. So that according to that, it is a classified. It was classified. So suppose you can see calcite. The calcite, okay, now you can scratch on a streak plate. Yes, definitely we'll get something color on a streak plate. Up to 5, almost we will get it. From 6 onwards, we are unable to get. We are unable to get the color. Because of the hardness. It is high. So that is the reason we are unable to get the color on streak plate. Only white we will get because of hardness is high. So here talc is 1, gypsum is 2, calcite 3, fluorite 4, apatite 5, clay 6, quartz 7, topaz 8, corundum 9, diamond 10. These are the minerals are representative for the mole hardness scale. So here beside column you see here it is mentioned the similar hardness. Graphite clays also having the one. Sulfur halide, muscovite, chlorite also having one. Barite, biotite, native copper, gold, silver have 3. Fluorite 4. And siderite, dolomite, aragonite, malachite 4. Apatite, limonite, serpentine, kyanite, it is also 5 equivalent to the apatite. And leucite, nepheline, sodalite, amphibole, pyroxene, epidote, pyrite, rutile, hematite 6. Garnet, kyanite, alvin, sassafite. It's a Andalusite, and these are all having the 7, where it is a 9, and final 9 and 10 are diamonds. Diamond which are very hard, not similar to that any other mineral. So soft minerals and hard minerals, there are 2 categories are there in Nilagora. You see here, Frederick Morse, he was from German, but not Australian Canadian. Yes, you see. Don't get confusion. Okay, now this is the arrangement of, you see here, the arrangement of minerals in our laboratory. Also, just you can see in a practical class. In a practical class, just you can check out that. You will get a similar box. It is there. Just you see in a practical class. Madam will explain to you at the time. And next property, it is tenacity. The tenacity and whether the mineral it has a breaking or bending property, or maybe it is a tearing also. So the property it is known as a tenacity. Different minerals are having the different tenacity property. So the term we will say brittle or malleable, elastic or flexible, sectile or ductile. These are the terms which are useful depend on there, and having the mineral tenacity. We will explain that. Yeah, again, specific gravity it is also there. The specific gravity it is a weight and the strength of a mineral it's a giving, and yeah, specific gravity it is very useful to find out our identification of a mineral. So because of a specific mineral means it is a strength, and whether it has a mass volume also we will calculate the availability of equal amount of a water while it's forming. The specific gravity will be calculated, and uh, the water it will be evaporated or at 40 degree centigrade, and those will be we will be calculate that a particular strength and weight. You keep in your mind simply strength and weight, the way of weighing of mineral. So the property it is leads the property which is showing, and feel how we will feel that whether the soapy feeling or greasy feeling or smooth surface or rough surface. Uh, that's also important to explain the mineral property. And taste, some of the minerals are having this alkaline taste or sorry, acidic taste or salty taste. These bitter and sour taste will be there. Yeah, it's a no need. These are all the no need. Yes, some of the gemstones. Yeah, here some of the gemstones also there. These uh, gemstones are looking very beautiful stones, beautiful stones like, uh, and which are useful for fashion into the jewelry. The gems also we will study the gems also in our subject. Example ruby, sapphire, and which are both are related to the corundum composition. I mean Al2O3. Some of the fells like aragonite, calcite related, and the turquoise lapis lazuli, it is known as a lazurite, garnet topaz, opal, it is a chalcedony, and aquamarine blue berries and amethyst quartz related amethyst. Those are also will count as a uh, gemstones category. Yeah, those are all the questions will be there. Yeah, here now we can see the classification of minerals. Yeah, here yeah, again I'll wait. I'll show you. Here there are different types of minerals are there, mineral groups, in like feldspathic groups. Yeah, in your textbook it is mentioned as the group it is mentioned the mineral families. According to that, mineral families: nesosilicates, orosilicates, cyclosilicates, and inosilicates. Like example here, feldspar group. Feldspar group means it is a family of a group of minerals. Feldspar it is a family of a group of minerals. So this example I'll tell you. This one, for example, wait, no, no, no. It's in the feldspar family. It is the best example for this one here. It is a tectonic family. Yeah, pillosilicates are the best example for that mica. The feldspars only, I'll explain only one this group to you. In your textbook, it is mentioned different, but as well time it is not sufficient to us for all the explanation purpose. So in a classroom, I'll explain. In a laboratory class, we'll explain definitely. Yeah, here most of abundant of all these silicate minerals, you see. The name of refers to group, not a single mineral here. Uh, you see, monomineralic and triclinic crystals are aluminous crystals are there. Here in a feldspathic compositions, we have common minerals. The following are common minerals: orthoclase feldspars, albite, anorthite, These three are the best example for this one. These three minerals. Any mineral, it has a own crystal system. Here it has a monoclinic system. I told you in a previous class the monoclinic system, the classification of a monoclinic system. So the chemical composition, what is the chemical composition here? Here the chemical composition example for if you see the potash feldspars. The potash feldspars of chemical composition potash, you see potassium means K and alumina silicates. Alumina silicates means Al should be there and Si should be there, O should be. So here KAlSiO. But the composition here, the ratio of a silicon and oxygen, it is a 1:3 almost. So that silica maybe if it is a 3 and the oxygen components will be presented in a 9. But actually oxygen composition will be dropped here so that instead of that the aluminum will be joined. So automatically KAlSiO8 will be forming. So this is potassium feldspars. And sodium feldspars, it is NaAlSiO8. Calcium feldspars, Kal2Si2O8. Because of two, depend on their availability of ions. The ions, while the formation of these mineral, it's required two molecules of ions and two molecules of sorry silica and two molecules of eight molecules of oxygen. So in this case, aluminosilicates, we'll call it as aluminosilicates. So here in all the way, the alumina will be present in all the metals. KAl3SiO8 orthoclase or potash feldspar will call. Sodium feldspars or plesioclase feldspars will call, that is known as NaAlSiO8. And albite or calcium feldspar, it is known as a Kal2Si2O8. This it is almost isomorphous series, almost equal elements will be forming here. Next one, it is atomic levels. The atomic structure of feldspars, different atoms are there. They depend on their availability of a linkage and availability of a oxygen bonding one ion to the another ion. So here it's a required 1:4. So the classification also we can see here, the classification potassium feldspars and potassium lime, soda lime feldspar. These two are there. Potash feldspar orthoclase, soda lime KAl2, soda sanidine. Sorry, potash feldspars are orthoclase, sanidine microclean. Microclean and orthoclase both are same, and sanidine it is also having the same composition. Soda lime feldspar. Here the soda lime feldspars. These are called as a plesiocal feldspar. The example for this one, NaAlSi3O8 and KAl2Si2O8, albite, algoclase, andesine, labradite, bentonite, and orthite. It is a ablala we will call from down onwards. It is known as a albite anorthite series. Ablala. Ablala means anorthite, bentonite, labradorite, andesine, oligocene, and albite. These are so only just these are all the examples what I'm telling you, and similarly the same whatever minerals just you can see here which are having physical properties. The feldspar you see here the physical properties. This one form, it is a tabular form or a mineral. It is occupying in a uniform thickness. Color generally we see it is a uh, pale or pale red, because pale gray or pale red or pink color also. And streak white, white color. Luster, vitreous luster, fracture, it is uneven, even to uneven. The arrangement of atoms are a different structure which are having. So, which is forming in the same cleavage. It has a two sets of a cleavage. Hardness 6, density 2.5. It has a medium occurrence. Maybe we can see it is in, sorry. Yeah, we see it is in igneous formation. igneous formation. Occurrence and mode of occurrence, we see it is an igneous formation and it has a weathering also. So these are the properties we can see. It is a, we see in any type of a mineral, any type of mineral it is having. So that in a mineralogical group, or maybe you see any mineral group, we will study these following the characteristics, physical characteristics, and definitely it has a chemical composition also. We should write the chemical composition. Okay, these are the properties of having. Okay, now I'm stopping here. And the same, some of the minerals are there. Those minerals are non-metallic minerals or non-silicate minerals also there. Example for chalcocite, bornite, galena, cobalite, cinnabar, molybdenite, graphite. These are all the non-pyrite. It is also FeS2. These are all non-silicate minerals, and oxide minerals are the cuprite, hematite. Oxide minerals, cuprite means CuO. Hematite means iron ore mineral P2O3. Magnetite, corundum Al2O3. Ilmenite Fe2O3. It is titanium oxide, rutile TiO2. These are all these oxide oriented minerals. Some of the halides also there. These halides, rock salt will halide. Example for this halide NaCl and cryolite, fluorite mineral will be there. So CaF2, apatite so also. Some of the carbonate minerals like calcite, magnesite, aragonite, dolomite, protosite, azurite, malachite. These minerals, and some of the evaporites. Some of the evaporites means here which are associating with the rock evaporation. Suppose these are all will be there along with the water bodies. So maybe in a summer season, these rocks are getting the evaporated. So these are called evaporated minerals or evaporite. Example for this anhydrite and gypsum mineral. Gypsum mineral, phosphates. Apatite is the best example for this one phosphate. So these minerals are belongs to the non-silicate minerals, non-silicate minerals. In a examination point of view, the questions will be done in a short, in the form of short question. Example, write the explain about the crystallography and minerals. What are the isometric system? What is the isometric system? And write the example for that one. Monoclinic system. What it is the monoclinic system? Explain with suitable examples. What is isomorphism? Explain with suitable examples. In a long question point of view, you should prepare that normal classification of isometric system and normal classification of a monoclinic system. Write about beryl system. Explain the define mineral. Explain the physical properties of minerals. The questions will become like that in laboratory classes or in offline classes. They will explain. Okay, if you have any doubt and you contact me, and I told you I have given my number and you have created a group also, you post in a group if you have any queries. I'll send you this PPT into the group. Thank you.
సార్ పీపీటీ గ్రూప్ లో వెళ్తారా సార్ కాస్త